Okay, this is lesson 7 from unit 3. This is a functions review over linear, absolute value, and quadratic functions. Now on number 1, we have f of x equals negative 3x plus 5. Now this just kind of popped up in some of our other stuff so far. This is a linear equation. So parent function, we're going to say this is linear. Now what do we mean by linear? It means that we're going to get some type of diagonal line. No vertex, no changes. Okay, we have a consistent rise over run. Now we are really comparing this to y equals mx plus b. Okay, now notice that our x does not have an exponent higher than 1. We have no absolute value. That's another way to recognize this situation. So we have a slope, an m value, and we have a y-intercept, the b value. Okay, so again, m means slope. Our slope is negative 3. We would think of it as negative 3 over 1, which means we're going to be going down 3, right 1, but down 3, right 1 of where? Well, that's of our b value, which means our y-intercept, where we start on the y-axis, and the b value is 5. Okay, there's only two numbers when you're in slope-intercept form. One's a slope, one's a y-intercept. So for this, we need to graph it first to answer all the other questions. We're going to start at positive 5 on the y-axis, so 1, 2, 3, 4, 5. And then from here, we're going to get our next points by using the slope, down 3, right 1. So 1, 2, 3, right 1. And keep doing that. 1, 2, 3, right 1. Okay, we could go back to our original one right here and go up 1, 2, 3, left 1. And then we connect our points. So you should be able to see we have this diagonal line. Okay, there's no vertex. There's no changing. It's always going downwards consistently in the same manner. That's what a slope means, consistent rate of change. What is the domain? Okay, when we have a linear function, our domain, how are we spreading out from left to right, or what x values can we put into it? It is moving left forever and right forever. So we would say the domain is all real numbers. The range, okay, my two arrows are going in opposite direction in accordance to up and down as well. We're going up forever and down forever without any breaks or gaps. So I would say that the range is also all real numbers. Number of roots. Okay, roots right here means how many times do we cross the x-axis? Okay, so we're looking, my x-axis is here. How many times do we cross? We cross 1 time, so this has 1 root. Okay, so all linear functions only ever have 1 root because it's only one line. It doesn't change and turn other directions, so it can't cross more than once. End behavior. Okay, this is all about how you interpret this. This right here says, as x approaches infinity. This means as x approaches infinity, positive infinity for x means to the right. So as we move to the right, f of x approaches. That's what the arrow means, approaches. What is it getting close to? Remember, f of x is the same thing as y. So as we move to the right, are we headed up or down? So as we move to the right, my arrow is headed down, and down would be negative infinity. So that's what we're going to put here. Now, the next part says as x approaches negative infinity. So negative infinity is on the left side of the x-axis. So this means as we move to the left, where is y headed? Where's our arrow headed, up or down? So as we move to the left, this arrow is moving up as well. So that's positive infinity. Okay, so there we go. Now increasing and decreasing interval. Now this is a little bit different, something we've done before. This increasing interval wants to know for which x values is our line moving upwards. Okay, so we read this from like left to right. As I move from left to right, is this diagonal line ever moving up? No, it's consistently moving down. I'm going to kind of show it here. It's consistently moving downwards. So we do not have any increasing interval here. We'll put NA. It does not apply. Decreasing interval. As we move from left to right, for which x values is our line going down? Well, as we move from left to right, this arrow, okay, this is always moving downwards as we move from left to right. It's never not decreasing. So we would say that our decreasing interval would be from negative infinity. From the left, we talk about x values from left to right. The furthest left we can get is negative infinity, the furthest right, positive infinity. So we're going to say from negative infinity to positive infinity, we are always decreasing. Okay, number 2, our function is f of x equals the absolute value of x minus 1 minus 4. So what's our parent function? What family does he belong to? Well, this is absolute value, and that's pretty obvious because we see absolute value bars. Sometimes we go with the obvious here. I'm going to use vertex form to help me plot this. My vertex, okay, remember we take what is inside the bars and we take the opposite value. So if we have -1, it becomes +1. The y value for the vertex is what's outside the bars, and we do not change that. So my vertex is going to be at 1. So 1 right and 4, 1, 2, 3, 4 down. And we're going to plant a dot right there. What is our slope to generate our other points? It comes from what is out front of the bars, in front of x, and that would be an implied 1. And that would be 1 over 1. So up 1, right 1 to make our next points. Okay, so we got this, and we mirror that as we work to the left. Go up 1, left 1. Okay, so we got this nice V. We're going to connect all of our points. Okay, now that we have the picture, we'll answer the rest of our questions. If you recall, domain for all absolute value functions, as we move left to right, we're moving to left to right forever with no gaps or breaks. We would say the domain is going to be all real numbers. Now, because both my arrows are ended going up the same direction, we at least have to be going opposite directions to get all real numbers. So we can't be all real numbers here. We look for our vertex, our maximum or minimum. I have a minimum value here, a lowest point. And what's the y value of that lowest point? I'm going to say that's -4. And then my arrows are going up. That always tells me that my values are getting larger. So we would say our range is for all the y's such that y is greater than or equal to -4. Okay, number of roots. How many times are we crossing the x-axis? So my x-axis, again, it's here. So notice we cross the x-axis. This absolute value function in particular crosses twice. It at most can cross twice, and this does. So we have 2 roots. Again, a root means how many times we cross the x-axis. Now, end behavior. Again, this is kind of new. End behavior, as x approaches infinity, infinity is to the right. As we move to the right, where is my arrow headed for y? Is it headed up or down? Those are basically my 2 choices. So as we move to the right, my arrow is going up. So that means we are headed to positive infinity for f of x. As x approaches negative infinity is all the way to the left as we can go. So as we move to the left for this graph, where's y headed? Well, it's still headed up. So we are also headed to positive infinity. When you're doing absolute value functions, the end behavior should be the same because both arrows end going the same direction. So it's pretty awesome. Now, increasing interval. For which x values is my slope positive as we move from left to right? So now notice, again, I'm kind of talking about slope. From left to right, look, we're going down until we get to the vertex, and then we start moving up. So this is a decreasing, this right side is increasing. So for what x values, though, are we increasing? This x value would be +1. Okay, that's at my vertex we changed. The x value of that vertex was +1. And then we are increasing forever after that. Well, where's forever? That would be infinity. So we would say from 1 to infinity, those x values, our slope is going up, increasing, going up. For which x values are we decreasing? Well, from left to right, this arrow, if we extend it, it's coming out of negative infinity basically because it has no end in that direction. So it's coming from left negative infinity here, I'm going to write that, and it's going down until we get to the vertex, and again that value of the vertex for x was 1. So we would say from negative infinity to +1, this graph is decreasing, has a decreasing interval. Oh my goodness, you guys, I just found out I did this whole problem number 3 without hitting record. Whew. Well, let's see if I'm better the second time around. Not that you'll ever know, but we'll pretend. So on number 3, we have f of x equals negative x squared plus 8x minus 11. Okay, we need to start by graphing this. But again, I'm going to look right here because we have x squared. That tells me we have a quadratic, and a quadratic means that we have a parabola. Now, do we have a happy parabola or a sad parabola? Because of this negative sign, I said negative people frown. So this is, or they're sad, so we frown. It's going down. That's the type of parabola I'm expecting here. So we need to start by creating a table of values if we didn't have our graphing calculator, so we could plot the points of this parabola and then answer all the questions on the right. If you're doing this by hand, you start by finding negative b over 2a. That's the x value of the vertex. So that would be negative 8 over 2 times negative 1. We get negative 8 divided by negative 2, which is positive 4. And that's the x value of the vertex, so I'm going to put it in the middle of our table. Then I would plug 4 in for my x's to see what I get for y. So I would have negative and then 4 squared plus 8 times 4 minus 11. And that's going to equal positive 5. So my vertex is at 4, 5. We're going to start at the origin, go 1, 2, 3, 4 right, up 1, 2, 3, 4, 5, plant our dot. And again, I am expecting my arrows to go down here because this was a negative parabola. Sad parabola. Filling in the rest of my points, to the left of 4, I would have 3, 2, and 1. To the right, 5, 6, and 7. Now, I'm not going to show it, but plugging in each of these values in turn, because we should know how to do this point. Plugging 1 in for x will give us negative 4. Plugging in 2 for x, we get positive 1. 3 for x, we get positive 4. And then these values repeat on the opposite side. 4 for 5. When we plug in 6, we get 1. And when we plug in 7, we get negative 4. Okay, just making sure I'm still recording. I am. Okay, so on either side of that, we're going down to 4. On either side of that, we are at 1. And on either side of that, we're down to negative 4. So 1, 2, 3, 4 here and here. All right. So what is my domain? My domain, we have left to right spread forever without any breaks. So we would say my domain is all real numbers. My range, okay, where do we cover the y values for this graph? We have a highest point at our vertex. That highest y value is positive 5, and it's everything below that. So we would say our range is all the y's such that y is less than or equal to positive 5. Okay, how many roots do we have? How many times do we cross the x-axis? That's what roots are. So you can see as I drew that line across that we crossed the x-axis twice, so there are 2 roots. Now in behavior, it's all in the way we read this here. As x, that line to infinity means as x gets close or approaches infinity, what is y doing? Now again, y is our up and down or vertical movement. So we're either going up or we're going down. So positive infinity is the right side of x. So as I get close to positive infinity, notice this arrow is going down. Down for y is negative infinity. So that's what y is approaching. On the next piece, we say as x approaches negative infinity, that's the left, right, for the x-axis, negative infinity. So as we come over here to negative infinity, get closer to that, my other arrow is also headed down. So we also say it's approaching negative infinity. And again, this is like the absolute value function. When you have absolute value, your v or the parabola, the rainbow or the U-shape, the arrows are always ending in the same direction. So that means that their end behavior has to be the same. Okay, now for our last piece of this, we have increasing interval and decreasing interval. So again, this is referring to for which x values, okay, for which x values is our slope going up, and for which x values are slope values going down for decreasing. Okay, so remember that the vertex is the turning point. So here's my vertex. As I come from the left side, from writing this line and moving to the right, it's going up. So this side is increasing. Now again, I'm not asking like the y values here. I'm talking about x values. So from negative infinity all the way from the left as I could get to this x value of the vertex, which is positive 4, I am increasing. So we would write that in parentheses, negative infinity for x to positive 4 for x. We have a positive or increasing slope. Now after positive 4 for x, that's our turning point, our vertex, we start going down forever. That down part is what means it's decreasing, but what is the x value as we move to the right forever? It's positive infinity. So we would say from 4 to positive infinity, we are always decreasing for y. Again, just because it's going down, that does not make this negative infinity. It means from left to right, the rightest we can get is positive infinity. The decreasing part accounts for it going down. Okay, on number 4, we have f of x equals negative, then absolute value of x plus 6. So what's our parent function? If I see absolute value bars, my parent function is absolute value. Okay, so let's use vertex form to graph this if you're not using a graphing calculator. My vertex, okay, what are my coordinates here? I take what is being added or subtracted inside with x and take the opposite. Well, if I don't have anything being added or subtracted with x, the x value of the vertex is 0. The y value will be the 6 that's on the outside, and it stays the same. So we're at 0 for x, 6 for y. So going up 1, 2, 3, 4, 5, 6, planting our dot. What is my slope? My rise over my run. That's the value in front of the bars. I have a negative sign, which means negative 1 over 1. We are going down 1, right 1 from this point. So down 1, right 1. We would go down 1, left 1, mirroring that on the left side. And let's connect our points. We got our nice V here. Okay, so let's answer domain and range. Domain, we are moving left to right forever without any breaks. So we are going to say our domain is all real numbers, and it is for all of our absolute value functions. My range, I'm looking for a highest or a lowest point. I have a vertex that's basically it's the maximum, it's the highest point. The highest y value is positive 6, and it's going down those arrows. So we would say less than 6 is what our y's are covering. So we would say our range is all the y's such that y is less than or equal to 6. Roots mean how many times we cross the x-axis. So here's the x-axis. I crossed once, twice. So we have 2 roots. Ending behavior. So as x approaches infinity means as we move to the right, where is y headed? So the right for x is here. As we get close to positive infinity, notice this arrow is headed down. So we would say down for y means negative infinity. Okay. As we approach negative infinity for x, that means as we move to the left, here's negative infinity. Notice this arrow is also going down. So this y value is also approaching negative infinity. They end the same direction, so it makes sense that these two are the same. Okay, increasing and decreasing intervals. Where do we have a slope that's moving up, and where do we have a slope that's moving down? So the vertex is always our turning point. As we move left to right, which is the way we should read graphs, from left to right, I'm going up until the vertex here. And it's the x value, so the x value of this vertex is 0. And then on the right side of the vertex, we are decreasing, going down. So this side is my increasing. The right side is my decreasing. But again, it's not asking where it's headed. That was end behavior. Increasing intervals and decreasing intervals. These are the x values. Okay, x values for these points. So we're coming from the left. The leftist point we get, again, is negative infinity. So from negative infinity to the x value of the vertex is 0. We are increasing. Negative infinity to 0. Then we pick up what that number we left off from the vertex from 0 to the right forever. For x would be positive infinity. Our slope is going down. And that's our increasing and decreasing intervals. Okay, number 5, we have f of x equals 2 times x plus 2 squared minus 7. Okay, as soon as we say a squared, that means that we have a quadratic. That's our parent function here, meaning we're going to have a parabola. We're going to have a happy parabola or sad parabola. Okay, 2 is positive. That's our a value. So we end up with a happy smiling parabola, arrows ending up. Okay, I love this one. It's in vertex form already. We don't need to do negative b over 2a, my vertex. We're going to take what's inside with x and make it negative, and take that outside number, negative 7, and leave it the same. So my vertex is negative 2 and then negative 7. So here's the origin, 1, 2, and then down 7 places us here. Okay, now if we plug in points to the left and to the right, we're going to do negative 3, negative 4, negative 5, and negative 1, 0, and 1. Okay, I'm not going to take time to show this all because we should be able to do it very well by now. When we plug in negative 5, out comes positive 11. For negative 4 for x, we get positive 1. For negative 3, we're getting negative 5, and then we mirror that on the other side. When x is negative 1, y is negative 5. When x is 0, y is 1. When x is 1, y is 11. So finishing up plotting those points, we're at negative 1 and negative 5 at either side, and then we're at 0 and 1. Notice this is skinnier than usual. We had some stretching going on, and that's the last point I can plot. But we have enough to connect these points. Woohoo! Okay, there we go. So what's our domain? We are spreading from left to right forever, so our domain is all real numbers. When it comes to range for quadratics or absolute value, we're looking for a highest or a lowest point. Okay, we have a minimum, because this was a happy parabola, we've discussed that. That minimum value for y is negative 7, and it's going up. So we would say that the range is all of our y values such that y is greater than or equal to negative 7. How many roots do we have? How many times do we cross the x-axis? So writing along here, we cross once, twice. So we have 2 roots again. What is my end behavior? Okay, end behavior, as x approaches infinity, so as we move to the right, where is y headed, up or down? So as we move to the right, when we're on this side, I can see my arrows are ending up. So it's ending or headed towards approaching, however you want to say it, positive infinity. As x approaches negative infinity, as we move to the left, okay, the left for x, where are we headed for y? Well, it's headed up as well, so it's also headed towards positive infinity. Again, they match because the arrows end the same direction. Increasing and decreasing interval. Okay, so we're thinking, as we move from left to right, where do we have positive, negative slopes? Again, I know the vertex is the turning point. And again, I am talking about x intervals here. We need to be thinking x intervals. Yes, we're talking about slope, technically, but it's for which x intervals our slope is going up and down. So we read graphs from left to right. So coming from the left, I notice I'm going down until I get to the vertex. After the vertex, which that x value is negative 2, we turn around and start going up. So going down this side, we are decreasing. On the right side, we are increasing. And again, for which x values are we doing that? You always have to think left is negative infinity until that x value of negative 2. That side we are decreasing. So I'm going to write that down here. From negative infinity to negative 2, we have a slope that's going down as we come from left to right. My increasing interval, we start increasing at negative 2 for x, and then moving to the right forever, we are always increasing that slope. So we would say positive infinity. Okay, number 6, we have f of x equals 5/2 x minus 1. Notice that the x is not squared, and I don't have any absolute value. So we are dealing with a linear function, which means we're just getting a diagonal line of some sort here, because we do have some slope. So it's not horizontal, it's not vertical. So again, thinking of how this compares to y equals mx plus b, m is slope, the number in front of x is going to be 5/2, meaning we're going to go up 5, right 2 to generate points. But what's our starting point? That's the b value. That would be the only other number in the equation, -1. So we're starting at -1 on the y-axis, and then we're going up 1, 2, 3, 4, 5, right 2. 1, 2, 3, 4, 5, right 2, about right here. We could go back to the starting point and go backwards by going down 1, 2, 3, 4, 5, and left 2. So we have this nice diagonal line. Notice we do not have a vertex. We do not have a turning point. It's always increasing. So what is the domain? Notice we are going to the left forever, to the right forever. Arrows are headed in opposite directions, so our domain here is all real numbers. I like linear equations because it's the same thing for the range. One side's moving up forever, the other side's moving down forever, no breaks, so our range is also all real numbers. How many roots do we have? How many times do we cross the x-axis? So I'm writing along the x-axis 1 time, and that's it. So there's 1 root. My end behavior. Okay, so as x approaches infinity, as we move to the right, where is y headed, up or down? So as we move to the right towards positive infinity, this side is headed up. So it's headed towards positive infinity. As x approaches negative infinity, we're saying as we move to the left, okay, the left, we're headed towards negative infinity. That's why I had it there. Notice that this arrow is ending down, so it's negative infinity. So linears, because their arrows are ending in opposite directions, should have opposite end behavior, like we do here. Increasing and decreasing intervals. Notice we don't ever change direction. We don't have a vertex. We have no turning point, so we're always headed in the same direction. From left to right, it's always moving up. It's always increasing. It's never decreasing. So we're going to put NA on decreasing interval. And because it's going up always, we're saying it's coming from the left, which is negative infinity, ending at the right as we can go, which is positive infinity. It is always increasing, in other words. Okay, number 7, we have f of x equals negative, and then x minus 5 squared. Okay, squared, that's important, and then plus 6. As soon as we say squared, that means parabola, which we call a quadratic for some strange reason. Quad doesn't mean 4 here. Because I have this negative on the outside, I say negative people are sad and they frown a lot, so our arrows are going to end going down. Those are things we know. So let's make a table of values here. We are in vertex form. I know we are in vertex form because we have parentheses around our x and a number value, and then it's squared on the outside of that. Okay, so my vertex, I take what's opposite with x, so we make it positive 5, and then the y value that's on the outside stays the same. So 5, 6 is my vertex. We're going to go right 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6, dot. Okay, our points on either side, we've got 4, 3, and 2, and 6, 7, and 8. We're filling on the x side of the table. When we plug in positive 2, we get out negative 3. When we plug in 3, we get out 2. When we plug in 4, we get 5. When we plug in 6, we get 5. When we plug in 7, we get 2. And when we plug in 8, we get negative 3. Now this shows that our points are getting lower, which is what we needed to happen here. So down to 3, or to 5, and then down to 2 on either side of that. I can't really see the x-axis very good. And then we're going down to negative 3 on either side of that. So 1, 2, 3. Okay, here we go. Connect the points as best you can. Okay, our domain, the domain for quadratics doesn't change. We have outward spread forever, all real numbers. My range, what's my highest point? Okay, because we are a sad parabola, we have a maximum. That maximum y value was 6, and then arrows are going down, so they're getting less than. So we say all the y's such that y is less than or equal to positive 6. How many roots do we have? So I'm writing along the x-axis. I'm crossing once, then twice. So we have 2 roots. End behavior. As x approaches infinity means as we move to the right, where is y headed? Okay, so as we come out here to the right, where infinity would be, I notice that my arrow's headed down, not up. So that's negative infinity. As x approaches negative infinity means as we move to the left for x, where is y headed? So negative infinity, as we move to the left, the arrow is also ending down. Negative infinity again. Increasing and decreasing intervals. Okay, think about where our turning point is. What's the x value of that turning point? It's the x value of our vertex, which we know is 5. Okay, and we're always coming from negative infinity. So coming from the left to the vertex, we are writing left to right always. That's how we read it. It's just how we work in math. We are going up. So this is my increasing interval. So those x values are from negative infinity to positive 5. We are having a positive slope. Now, we pick up where we left off with that same number. From positive 5 to the right forever, this always is going down. But again, the rightest x value is positive infinity. So from 5 to infinity, we are always decreasing with our slope. Okay, our last example for our review, on number 8, we have f of x equals 1/2 times the absolute value of x plus 3, and then adding 3 outside of that. I said absolute value, so that means my parent function is absolute value. Okay, we can always use vertex form here. So vertex, my x and y value here, my x value will become -3 when we pull this out. It's always the opposite. And then positive 3 for the y value. So -3, positive 3 for the vertex. So 1, 2, 3 left, up 1, 2, 3. Now my slope is the number in front of the absolute value bar. So my slope is 1/2, meaning we go up 1, right 2 for that from that vertex. So up 1, right 2, dot. Keep on doing that over and over again until you run out of room. We come back to our vertex, we go up 1 and left 2. And we're going to connect our points. So there's our V. The domain is still the same. It's all real numbers. We're spreading from left to right forever. My range, my lowest y value. Okay, here's my lowest point. The y value for that point is positive 3. And my arrows are ending up. So our values are getting greater. So we're going to say all the y's such that y is greater than or equal to positive 3. Number of roots. It's kind of a trick question. Here's my x-axis. I'm riding along it. Because my vertex was above the x-axis and my arrows are ending up, I never cross the x-axis. So on this one, we say we have 0 roots. That can happen, like I just did. Now, end behavior. As x approaches infinity means as we move to the right, okay, here's infinity moving this direction, my arrow is ending up. So we are ending or approaching infinity for our y value, which again is expressed by f of x. As x approaches negative infinity means as we move to the left, where is y headed? So y is headed up on this left side as well. So we're going to put positive infinity. Again, they match because they end in the same direction. Increasing and decreasing interval. Remember, we changed directions at the vertex. This is all about my x values for my increasing and decreasing intervals. So the x value of my vertex was -3. The leftist point I can have for x is coming from negative infinity. So from left to right, so from the left to the vertex, we are going down to get there. So we are decreasing. So my decreasing interval is what I'm going to write down first. From negative infinity from x to -3 for x, we are headed down. After the vertex, we turn, called a turning point for a reason, and we start going up to the right forever, which is positive infinity. So from -3 for x to positive infinity for x, we are always having a positive slope. Okay, that is our review. This is it for Unit 3. After this, we'll do our study guide, and we will have a Unit 3 exam. Best of luck.